Good afternoon, everybody. My name is Thomas Grünig. I'm one of the 4 managing directors of the HSD company. And I have the honor to introduce you another solution of CSO reduction that the city of Graz established quite newly with a very interesting product. We heard already a lot about how to measure, how to reduce and the CSO overflow, and also what it can resulting in if the rivers are getting polluted through these events. So the city of Graz is located in Austria, in the southeast of Austria, and they had built, constructed a new deep tunnel collector channel. Here you can see first some effects of the sewage network. The city of Graz has about 860 kilometers of sewer pipes, whereof about 70% are of combined system. And it has been growing during the last decades gradually and is still growing. It has a treatment plant for capacity of about 500,000 people's equivalent. And the actual storage volume of the system is approximately 37,000 cubic meter. So it has 35 CSO points into the river. Here you see the river, a very nice river crossing more or less the city center of Graz. And due to this discharge after heavy rain event, about 660 tons of BOD per year is spilled over into the river. And this is due to about, in average, about 80 CSO events per year. So these amounts, these are the over the CSO points along the river, so the 35 actually, and they dispose about 200,000 cubic meter of combined stormwater and sewage into the river, which, as I mentioned, results in about 660 tons of BOD, which was not accepted anymore for the people, because this river is heavily also used for recreational purposes and also for fishing and these kind of things. So they an additional challenge to the city or to the river was the construction of a new hydro power plant that raised the upstream water level about 1.5 meter. So this here is the new hydropower plant. It's about 18 megawatt hydropower plant, and it was built between 2017 and completed in the year 2019. An additional channel is also the demographic development of the city is continuously have been growing. Now is about 350,000 in the city center, plus some people also, population living in the urban areas. But it's still growing, and they need to be prepared to cater for about 800,000 plus population equivalent. So what is the problem? The first problem is created after the construction of the hydro power plant, which raised the water level. And the problem is 18 CSO points that previously discharged into the river was submerged, were underwater, and could not really submerge, discharge anymore. 3 more CSO points were still downstream, that means after the new built hydropower plant, so this was not a bigger problem. So no emergency discharge per gravitation was possible anymore into the moor. So here this picture shows the city and the river, and the solution was to build a central storage tunnel along the river, to create an additional storage volume of about 100,000 cubic meter. The CST to be constructed below the existing sewer network. So it was about between 1 and 3 meters lower than the normal sewage network. The length of the new tunnel is 8.4 kilometers. It was built in 2 phases. The first phase was about 3.2 kilometers next to the water treatment plant that was here at the end. And this Moor hydropower station is about here in the middle or in the middle section. 21 of the total 35 CSO points into the or 21 of the total of the 35 CSO discharge points are spilling, ending up into the tunnel, and they created then now an additional storage volume of about 94,000 cubic meter. So, but this storage or deep tunnel storage tunnel does not work without some mechanical or some technical machines that sits into this tunnel, very important. And in order to activate the full capacity of 94,000, there was the need to construct so-called cascades. So there was 7 cascades created. That is due to the slope of 1.6 meter per 1,000 meter. So this cascading wears, increasing the or optimizing the utilization of the capacity. So the main function of the central storage tunnel was first to ensure the drainage in the long term, despite of the 2 hydraulic power plants. So up to about 80 cubic meter per second can be discharged into the Moor River during a 100 years precipitation event from the connected CSO upstream the hydropower plant. Secondly, the pollution load reduction into the river. But also a better inflow control towards the wastewater treatment plants. Also important for the maintenance, the temporary redundancy for the rehabilitation work in the main collector. And another goal was also this tunnel should be automatic cleaned by or clean out the sedimentation, because there was, for certain reason, also quite a lot of sand loads and gravel that spills into the tunnel. So here you see 3 of the 21 CSO points that are above the river. Here you see this is the water level of the River Moor, upstream the hydropower plant. So usually now all the water is collected now down here in the central storage tunnel by a floor gate. When the tunnel is full, then it opens and or it closes, and then the water is discharged directly into the River Moor. 18 out of the 21 CSO points discharged, they were submerged actually, as I said already, after the building of the hydropower plant. So here, this is the old CSO point. They are beneath the water level. So what happened? They closed it, they demolished it, and then made a connection from the existing sewer system down into the new built deep tunnel. So just now the concept of the storage activation with cascadewares, as I mentioned already, activation of the entire storage capacity makes there's the need for these vertical lifting wares. We call it ASA wares that are automatically operated and can be controlled by water level and control water level, flow, and other things. Here you can see on this picture how it works. It moves into the ground, and then when it opens, but here these cascades holding the capacity. The function is beside the activation of storage capacity, also flow and level control, as well as to create a surge flushing of the sediments, because all the time, on a regular basis, there's a cleaning function. They're creating flushing waves and moving all the sediments downstream towards the wastewater treatment plant. Here you can see the main dimension of these vertical lifting wares is about the width is 3.6 meters, the maximum height is 6.5 meters in this, and the moving speed up and down is about 7 to 9 meters per second. This is important that it moves down quickly, otherwise it cannot create a strong flushing wave. If the tunnel is full, for example, if there is a very heavy rain event and it needs to discharge into the river, there is immediately after or downstream of the hydropower plant an overflow that can handle up to about 80 cubic meters per second. And that is also measured and monitored how much they will it is discharged. So this is here the outflow of this discharge point just downstream of the power station. So mainly they used standard profile to build and to construct the tunnel, 3.2 by 2.5 meters. And on the downstream section, they are used a double tunnel to increase the capacity, and they're using the same dimensions of two of the standard tunnel construction. They also used a double one. It also has something to do with the structural, with the civil construction that makes it more easy and more and cheaper. Here you see in one of these this cascading wares when it is closed. So there are level meters, level centers upstream and downstream, yeah, here another view, and that is on the upstream side of the power station. Now just a few words to the technology of the ASA ware. The main components is the concrete, is this ware plate that moves up and down. It's constructed from solid concrete with a stainless steel skin, and it is powered by two hydraulic cylinders, right and left, and they sit in a frame actually. So they're moving up and down. When it is open, that there is no obstruction of the flow path at all. And it is controlled everywhere. Every ware of the 8 units are controlled by Nivus water level sensors, and they are evaluated by a PLC that sends the signal to the overall control box software. They send back then the preconditioned signals, and then operating the ware, so sends the control actions to the ASA ware. So the civil construction, just a few more words. How it looks like, this is one of the buildings constructed to housing the vertical lifting weighers. That was, the weighers are installed more or less in one piece together with the frame, just lowering from top to down. And an installation here takes about, if the concrete and the site is prepared well, it takes about 3 days to install one of these weighers. During the construction, there were some technical or some challenges. One is to protect the flora and the fauna, challenging soil condition, and the construction concept was they used sheet piling, Spundwände in German language, and they built it in an open construction. They used in situ concrete pouring, and in average they completed about 42 meters per 1 week. The cost was, for the first phase, about 580 euro per cubic meter, and the second, which is mainly the double channel, is about 1180 euro per cubic meter. So it ends up in a total cost of 82 million, which was even beyond the budget. So now here just at the end some impressions of the construction of the tunnel. So the excavation here next to the river, and the reinforcement, floor slabs, that was everything done very properly with a very good project management. So now the Fazit, after 2 years of experience, almost 2 years experience of the operation, the pollution reduction now is about 80% less into the River Mur. The safe and reliable emergency discharge out of the Graz sewer network has been secured and established. And also more operation flexibility and improved flow management into the wastewater treatment plant. Yes, so that is now, I thank you very much for your attention, and I also want to mention that information to this presentation was supported by Graz Holding Company, which is the operating company of the drainage system in Graz. And also the Technical University of Graz that carried out some simulation and also contributed to certain information that I just present here in this presentation. So I thank you very much, and if you're interested and have some further question, you are highly welcome to visit us at the Ecol Unicom stand here outside, which is our partner here for the Polish market. Thank you very much for your attention, and enjoy the late lunch. Thank you.